All right, let's get back to simplifying with exponent rules. So we won't be converting to radical form for this. We're just using our exponent rules to combine things and make these messy expressions a little bit neater. So really, we're just going to look at all of these, and while we do have fractions in the mix that make it look scarier, we're just going to use the exact same rules that we did earlier in the quarter when we reviewed exponent properties. Here, what I see is a big multiplication problem, but within each set of parentheses, I also notice that everything is multiplied. So the parentheses are really just indicating more multiplication and not serving a very big purpose other than that. I'd like to start by rearranging a little so that I can group together things that I'm going to be able to combine. This step can absolutely happen in your head if you're comfortable, but I'm going to write it all out so you can see how I'm thinking about this. I'm expecting to be able to multiply together the two coefficients, the numbers. So I'll group those together first. I also expect to be able to do something to combine the w's. So next I'll put w to the 3/4 times w to the 1/2. And I'll also hope to combine the y's. So I have a y to the 1 and a y to the 3/2. So again, you don't have to write this step in as you get going if you're feeling comfortable, but this is how I'm grouping things in my mind. So the first one, -2 times 3, that's just plain old multiplication, no exponent rules needed. But for w to the 3/4 times w to the 1/2, I will need exponent rules. And the rule I need says that if you have two things with the same base and you multiply them, you have to add the exponents. So I'll want 3/4 plus 1/2, and 1/2 is the same as 2/4, which means I'll get w to the 5/4 when I combine those two. Similarly for the y's, they have the same base, so I need to add 1 plus 3/2, but 1 is really 2/2. So 2/2 plus 3/2 gives me y to the 5/2. So these hopefully aren't going to be terribly messy. That's not really the point. The point is just to get a mix of your exponent rules in there and have you try and think carefully about which ones to use and how things combine. Okay, so let's do one that has a division and also some negative exponents. When we're simplifying, we do want to combine anything with the same base. We want to reduce fractions. We also want to make sure there's no negative exponents in our answer. Okay, so again, sometimes this is a frustrating thing for people, but as you get more comfortable, I think it's actually a nice thing that there are a lot of different orders you could attack this in. If there was any addition or subtraction in the mix, that would greatly tie up our freedom to do things in different orders, but everything here is multiplication, division, and exponents, and those are really close in our order of operations, so it gives us a lot of flexibility. So I am seeing two things that I feel like tackling first today. One is that I can reduce the fraction right away. The constants, 12/6 is 2, so I'm going to go ahead and do that as a first step. I think the thing that I would like to tackle next is the power to a power. So let's write what we have. We have a 2. I'm not doing anything with the k to the -1/2 yet, but I am going to say if I have k to the -1/8 and I raise that to the -2, I'm supposed to multiply powers. So I get a positive 2/8, which is 1/4. So multiply your powers, and that cleans up the parentheses. We have a k to the 5th on the bottom. All right, the next thing I think I'd like to deal with is the negative exponent, and that's actually one of the reasons I wanted to multiply powers first, is because that actually eliminated a negative exponent without me having to make any fractions and fractions mess or anything like that. So if I'm going to deal with the k to the -1/2, that's the same as a 1/k to the +1/2. And again, there's some room here to combine some steps if you can see it. You might see me getting ready to line up and make that top a single fraction. If I do that, I get 2k to the 1/4 on top, and I get k to the 1/2 on the bottom. And that's all over k to the 5th. Notice I made that bottom fraction bar bigger, and I want to maintain that. I want to keep track of where that big division is. And I think that's actually what I'd like to deal with next, is the fractions and fractions. Again, not your only choice. You could combine k to the 1/4 and k to the 1/2, for example. But I think the complex fractions are looking really ugly. So let's go ahead and deal with that. So I'll have 2k to the 1/4 over k to the 1/2. And I'm dividing by k to the 5th, which is the same as multiplying by 1 over k to the 5th. So when I mush that all together into a single fraction, I have this. And now I think I'm ready to do some final combining. So what do I have? Let's go ahead and combine the bottom two first. If you're comfortable, it is fine if you're combining a couple of these steps. To combine the bottom two, I'll have to add 1/2 to 5. So 5 is the same as 10 halves, which means that we will get k to the 11 halves. And then to do that final step, we need to subtract exponents. So 1/4 minus 11 halves. If we multiply top and bottom by 2, we get 22/4. So 1/4 minus 22/4 is negative 21/4. That negative means that my k should be in the denominator of this fraction. So it should be k to the 21/4. Another way to think about that, or an in-between step for you, would be that that means k to the negative 21/4. Your answer that you get when you subtract exponents would always be in the top of the fraction. So it's really just an additional step to then push that to the bottom of the fraction to make it positive.